AI Few-Shot and Zero-Shot Learning Deep Dive. How Senior Engineers Master Sample-Efficient AI Systems. Welcome back to Agentic AI World. I'm your host, and today we're diving deep into one of the most practically powerful topics in modern AI engineering, few-shot and zero-shot learning. If you're preparing for senior AI engineering interviews, this is a topic that separates the people who just read papers from the people who actually ship systems. Let's start with the basics, then get into the real engineering. Zero-shot learning means your model can handle a task it has never explicitly been trained on, with zero examples at inference time. You just describe what you want, and the model figures it out. Few-shot learning means you give the model a handful of examples, typically 2 to 10, and it generalizes from those to handle new inputs. Both techniques work because large language models and vision language models have learned rich, general-purpose representations during pre-training. Here's the key insight an interviewer wants to hear. The model doesn't learn during zero-shot or few-shot inference. There's no gradient update. The model's weights don't change. What changes is the context, the prompt, and through attention, the model conditions its behavior on that context. This is called in-context learning, and it's fundamentally different from fine-tuning. So when would you use zero-shot versus few-shot? Zero-shot works well for tasks that are close to the model's pre-training distribution, classification, summarization, translation, basic reasoning. If the task is unusual, niche, or requires a specific format the model hasn't seen much of, few-shot examples help dramatically. Think of few-shot examples as a behavioral contract. You show the model exactly what good input-output pairs look like, and it follows the pattern. Now let's talk about the engineering challenges you'll face in production. Challenge 1. Example selection. Not all few-shot examples are created equal. Random selection often underperforms. The best approach is dynamic few-shot selection. At inference time, you retrieve examples from a curated pool that are semantically similar to the incoming query. You embed both the pool and the query, run a nearest neighbor search, and grab the top K examples. This is often called a retrieval-augmented few-shot approach, and it combines beautifully with vector databases. In interviews, if you mention this, you immediately stand out. Challenge 2. Example ordering. Research shows that the order of few-shot examples inside the prompt affects performance. Models tend to be recency biased. They weight the last example more heavily. For classification tasks, you want to distribute label diversity across your examples and often put the hardest, most representative example last. For generation tasks, put the cleanest, most stylistically ideal example near the end. Challenge 3. Label space coverage. In few-shot classification, if your examples only cover a subset of classes, the model will underperform on unseen classes. You need to ensure your example pool covers all categories with roughly balanced representation, or you'll see systematic bias toward overrepresented classes. Challenge 4. Context window limits. When you're doing many-shot learning, say 50 or 100 examples, you can easily blow past your context window. The engineering solution here is hierarchical prompting or prompt distillation. You compress your example set into a compact representation that captures the essential patterns. Some teams even fine-tune a small adapter layer specifically to encode a large example pool into the model's behavior without consuming context tokens. Now let's talk about zero-shot chain of thought, because this is a common interview question. Standard zero-shot prompting tells the model what to do. Zero-shot chain of thought adds the magic phrase, "Let's think step by step," or something equivalent. This single addition dramatically improves performance on multi-step reasoning tasks, math, logic, code. The reason is that it forces the model to externalize its reasoning, which reduces the probability of early commitment to a wrong answer. In production, you often want to go further and use structured chain of thought. You define the reasoning steps explicitly and prompt the model to fill in each step. This makes the reasoning auditable, which is critical for compliance-sensitive applications like healthcare or finance. Zero-shot and few-shot learning also interact powerfully with instruction tuning. Models like the GPT series, Mistral Instruct, and Llama Chat variants have been fine-tuned specifically to follow instructions. This makes their zero-shot performance dramatically better than base models. When you're choosing a foundation model for a product that relies on zero-shot prompting, instruction tune variants are almost always the right starting point. One advanced topic worth knowing, meta-learning, sometimes called learning to learn. While zero-shot and few-shot prompting are inference time techniques, meta-learning is a training time approach where you explicitly train a model to generalize quickly from few examples. MEML, model-agnostic meta-learning, is the classic algorithm here. You train the model across many tasks so that its initial weights are positioned to adapt rapidly with a few gradient steps on any new task. This is a research-heavy area, but knowing it signals deep expertise. Now, calibration is a critical production concern. Models doing few-shot classification are often poorly calibrated. Their confidence scores don't reflect actual accuracy. You should always run a calibration step, collect model outputs on a holdout set, fit an isotonic regression or Platt scaling layer, and use calibrated probabilities in downstream decision logic. An overconfident model silently fails in production. Let me give you a quick system design sketch for a production few-shot classification pipeline. You have an incoming text input. First, you embed it. Second, you query a vector store for the top 5 semantically similar labeled examples. Third, you construct a prompt with those examples ordered by similarity ascending, so the most similar example is last. Fourth, you call the LLM with temperature near 0 for deterministic output. Fifth, you parse the output with a structured output layer, JSON mode, or function calling to get a clean label. Sixth, you run the output through your calibration layer. Seventh, you log the input, examples used, output, and confidence for monitoring. This pipeline handles cold start gracefully, improves over time as your example pool grows, and is fully explainable. Let me close with 3 interview power moves on this topic. First, always distinguish between the model learning and the model conditioning. Zero-shot and few-shot are about conditioning, not learning. Saying this clearly shows you understand the mechanics. Second, bring up dynamic example retrieval proactively. Most candidates talk about static few-shot prompts. Mentioning retrieval-augmented few-shot selection immediately elevates the conversation. Third, connect few-shot learning to cost and latency trade-offs. More examples mean more tokens, which means more cost and more latency. The optimal number of examples is an empirical question you answer by running experiments on your specific task and measuring accuracy versus cost per call. That's a wrap on episode 84. Few-shot and zero-shot learning are not just tricks. They're architectural decisions that affect cost, latency, accuracy, and maintainability of your entire AI system. Master them, and you'll answer interview questions that trip up most candidates. If this was useful, subscribe to Agentic AI World for daily AI engineering interview prep. See you in the next episode.